good. So let's get started. So the first thing we'll be looking at is the RDS, relational data store, and Aurora, and we'll also look at the Elastic as one of the other databases. That's the main agenda today. So while doing this, we'll switch back and forth between your real AWS console and the presentation to understand that we have good balance between real hands-on and also the presentations. Right, let's get started. So this is our agenda today. So what is that we are going to look at today, right? So we'll be looking at the RDS overview. What is RDS? It is a service where you can host databases. What kind of databases? Some relational databases. Example, SQL Server. What are you going to host? Oracle you want? All right, we can do that. MySQL, possible. Postgres, yeah. Then we have something called MariaDB. So normally, like our current supports these many databases, which can be created on RDS. So talking about databases, we need to talk about backup and security. Without that, any database is not complete, right? So obviously, ability to recover from a failure, and also the security of the data is very important. Since we are talking about cloud, security comes in the first thing, right? The first concern of everyone moving the data to the cloud is the security, how secure the data will be. So you have to implement the best practices while doing the security. Okay, that leaves that. So we have a Aurora. What is Aurora? This is managed instances, right? So whatever we get here is we get the entire software, right? SQL Server fully installed and done that, but Aurora takes it one level up. It's the fully managed service where scaling up, scaling down, and nothing you have to take care, right? And it is compatible with MySQL and Postgres, two of it. Okay, so now let's talk about Aurora security after that. So there is one more we'll be looking at today is Elasticache. Elasticache is nothing but an in-memory database, right? So there is no real data storage, but everything is on memory, right? So here, there are two options what they provide, Redis and Memcache, right? Two open source in-memory databases been provided by Elasticache, and that's what we'll be looking at today. And that's how it sums up our agenda. For a couple of hours, we'll be looking at these two options, right? RDS and Aurora, and Elasticache as well. There's actually three. All right. Okay, let's go. So next one, we'll start looking at RDS. What is RDS? The relational database service. Okay. So it's a relational database service. It's a managed DB service. What do you mean by managed? Where we do not no patching require, no licensing cost, no software cost. When I say no software costs, you don't have to install software, right? It all comes ready for you. So what else is your fully managed DB services? No maintenance. What else? Infrastructure. All infrastructure also provided by that, right? Entire infrastructure. That's the managed databases. So what are types of databases we can create? We just talked about, right? Postgres, MySQL, MariaDB, Oracle, SQL Server, and Aurora, right? It's a proprietary database. It's only available in AWS, but this is compatible with both MySQL and Postgres. And create an Aurora database, which is equivalent to, which is Postgres compatible or MySQL compatible. Both you can do it. Okay. So why should I go for my own RDS? I can even go and host this database on my EC2. I can purchase a EC2 machine on Windows. I can install my Microsoft SQL Server, right? It will work perfectly fine. That absolutely okay to do that, right? But imagine that you just going to use in 5 GB database, a quick solution you need without owning a database administrator, right? You don't have a database administrator, and you don't have time to to go for bringing up the operating system, patching, maintenance, and etc. Right? So RDS provides a managed service, right? Where the patching is taken care by AWS itself. Not only that, the backups for point-in-time recovery, automated backups, and you have a dashboard, fantastic dashboard to see how your database is performing, what is the CPU utilization, memory utilization, how many queries are coming at a time, is there any need for us, rehaul, restart of the machine, any errors, any events happening, all those things can be monitored properly. And we can have our own automated read replicas to improve the performance, where all your read queries can be directed to your read replicas. Okay. So let's talk about a little bit better on the multi-availability zone setup for disaster recovery. So you know that AWS have regions, right? Inside region, you have availability zones, like 1A, 1B, something like that, right? Each availability zones are independent of each other, but well connected. In case if one availability zone is done, the other availability zone will be up and running. So obviously you can use it for a high availability, right? What they do is they create a primary instance on, say here's a primary, this is a standby instance they'll create. In case if this goes down, your standby instance will get activated. So that's what they're talking about. Multi-AZ setup for disaster recovery. So again, maintenance windows for upgrades. So you have to choose a particular maintenance window, and within that window only, they will be doing all the upgrades. Okay. The next one is scaling capacity, vertical and the horizontal. I explained that before the session, right? Your vertical scaling is nothing but you're adding more CPU, RAM, and memory. So the horizontal scaling is about more adding more instances to take the load. So obviously it has both option to do it, and you can have an extensive storage option, which is like a GP2 or IO1. IO1 is like it's like IOPS optimized, right? So for the higher throughput and low latency. But there is a downtime too. And if you see what are the limitations, this is not fully featured instances where you can't do a lot of maintenance activities. Not all features are available like your standalone systems, right? There are certain limitations. In this limitation also includes you can't really log into your instances. So normally, if you take a SQL Server, DBA will be able to log into the Windows instance and perform some operation, monitor the services, restart something. Here, you cannot do that because since it's a managed service, you will not be allowed to SSH into your instances. That is big no. Okay. Talking about backups. So every DBA will have to live through this, managing their backups, but AWS takes it one level up where you don't have to be a database administrator to manage your backup and recovery. You can be a normal developer, a simple person like me who knows a little bit about cloud, then you should be able to manage this on your own. So it is that easy, right? Let's see what are the features on top provided by AWS in backups. First thing is they are automatically enabled in RDS. Okay, you don't have to clear. So the backups will be taken every 8 hours automatically, right? So it's like that. So you, by default, you when you bring up any databases in RDS, the backups are automatically scheduled. So during the maintenance window that give, full backup of the database will be done. Or not only that, every 5 minutes your transaction logs are backed up by the RDS. So obviously your point in time recovery will be every 5 minutes. Okay, and not only that, and you will be able to restore any lost data within the 5 minutes time. So anything happened before 5 minutes, you should be able to retrieve it back. And the backups are retained for 7 days by default, but it can be increased up to a month. Okay, that's automated backup. Sometimes we have to take our own backup as well. So we call them as snapshots in cloud. We can take DB snapshot. This is a manually triggered snapshots, right? And you can keep it as long as you want, right? There's no limitations here. And you can use this snapshot to actually go and spin up another instance. Okay. Right. Let's talk about auto scaling a little bit, right? We have been discussing about auto scaling. What is auto scaling? Ability to expand, resize based on the usage is called auto scaling, right? So RDS allows you to do a auto scaling. So RDS allows you to do a auto scaling. Okay. It helps you to increase the storage. Then you can manually scale whenever you need, and you can set a threshold. If it crosses the threshold, you take action. Okay, that's what it is. Very similar to your easy to auto scaling. We have seen it in previous classes. Your database also can be scaled up as per the need, right? One good example is the storage, because every time you see, we will run into various amount of data. So stored. So there is no need, there is a huge need to manage your storage, right? So in case your disks are full, you have to add additional disk and all those things, right? And here you can start with a very lowest storage, and you can keep adding your data as per the requirement, right? Look at this section here. So if the free storage is less than 10% of allocated storage, you can modify that. What do you mean by modify? I can add another storage, right? I mean, I can add more storage to it. That's what they mean. They can. And if there is a low storage, again, you can do it, right? So 6 hours passed since the last modification, you can go back and look for it and modify that, right? So this is required with the systems of unpredictable workloads. When you see a large data suddenly popping up into your database, a lot of data being dumped in, which is unexpected, and you're not ready to, increase the storage by the time. So obviously, you can set up your auto scale. And this auto scaling is supported in all the databases what we talked about: MariaDB, MySQL, Postgres, 12 SQL Server, and Oracle. All the databases supports this. Is ideally just increasing your storage. Please put in any questions that you have in the chat box so that I'll be able to respond while I take the session. And also keep your AWS credentials ready to log into AWS console. We'll be quickly switching to a AWS console hands-on on this one. Okay. Let's talk about read replicas. First of all, database itself, we have not really seen. What is a read replica and how it is different from a normal database? So assume this one, right? So I have a person So I brought up a new database, right? Let me do it over here. So this is the sample DB. So what I can do is, I'm a person who writes the data in, right? So I'm writing the data into database. So how do I do write the data? Either through the app, I'll be inserting the data into databases. At the same time, I will also start reading the data. But say that number of users is like the amount of people will be using is just restricted to say 1K. That's about 1,000, right? Then we have a group of pool of users across the globe, right? So who will come and read the database, right? So when they read the database, traffic increased. Obviously, the performance is going downwards, right? To avoid that, what they do is they do exact mirroring of this database, and they'll cause a read replica. And this will be a continuous mirroring will happen. If there's any records getting updated, it will be updated over here as well. But now we'll be using this with the large read groups. All the people who's reading will actually come and use this particular read replica. So when they do, the read replicas will take a lot of the read traffic from your original server. So all those people will not use it and they'll come and use the read replicas so that your load on the database is going to be very less. And here, RDS plays that very good in here. You can keep up to 5 read replicas and serve a number of users, right? So within the single availability zone or multi-availability zone or even cross region, in the different region also, you can create a different read replicas and work on it. Okay. So replication is asynchronous. What do you mean by asynchronous? So a person writes one record here, record A to the table, means if it will be, start replicating in the read replica. And the other write will not actually wait for that to complete. So they will write another B. So again, the B will be replicated to the read replicas. And what happens is the other write will not wait for the replication to happen. They will happen in synchronously. So that means whatever that you're reading are eventually consistent. What do you mean by eventually consistent? It's the data guarantee when you are reading those records, right? So there are chances that a couple of records are little outdated for a few seconds, right? So if you do one more read, then the recent records will come. So there are two types that you normally see: eventually consistent and strongly consistent. Strongly consistent is at any time you will not get any stale records. You will not get any incorrect data or lost up. Always you'll get the latest record in the strong consistency. But since it's asynchronous, you'll get the eventual consistent. Right? Also, the replication can be promoted as a full-fledged database. Means that you can also start doing a read and write at a certain point. So who will use the read replicas? All the applications which are using it. So they have to update their connection string to use this additional read replicas for the read query to utilize that well. Okay. So we are just looking at the read replicas for read scalability, right? How does it done? So this diagram allows you to visualize how an read replica works. So you have application, say it's your sample application, which uses the database, right? This is a sample application here. So I have a main database, a main RDS instance here, which handles both your write and read queries, both. Then what we will do is we'll create multiple read replicas like this, and it will have a asynchronous replication, and you'll get a eventual consistency when anyone reads from here. Okay. So when you do that, the huge application can use multiple connection strings for redistributing their read traffic, right? And obviously, the load on your main RDS instance will be less. So you may ask me that where do I use it? Where do I use your read replicas, right? So where can I use it? I can use it in a production database that's taking a normal thing. Suddenly there is a lot of people who come and read the data for the reports, analytics, and other stuff, right? So you can create a read replica for that new workload. To be in a very layman terms, read replicas cannot perform insert, update, deletes. It can perform only reads. Okay. So this is the application we normally talk about. We have a production application where we have a reporting application coming here, which has to read all the data and report based on different, say, Tableau, ClickView, any of the reporting analytics tools using it. So you can create a read replica and you can serve those requests separately. You don't have to be on the main server to do that. So imagine if I'm doing a read replica, how it's going to affect my cost, right? You need to be really mindful about using AWS services, with what will be the impact that will have on your databases. So there you can see when you are replicating within the same region, there is no network cost associated to it. But when you are doing a cross regions, right? When you're doing a cross region, and there is cost applicable. But within the same region, if you use read replicas and the same availability zone or different availability zone, there's absolutely no cost. So there's no cost involved for network traffic. I mean that for the data that you transfer from here to there, right? There is no cost. Only it comes into place when you have a multi-region read replicas. So how do I use it for disaster recovery? What is a disaster recovery? Something goes wrong, then how do you recover? How do I use your standby instance up and running, right? So here we use something called a standby instance. And here it's not asynchronous. Asynchronous is what we have seen in the read replicas, right? So it provides you the eventual consistency, and that's not going to work on your standby instances, because the standby instances should be up to date always, like a main instance, right? So what happens is it provides synchronized replication, and in record return to table A, also return to the same table in the other database, the standby database. So what you'll get a single DNS name in case the application fail, automatic failover to the standby, and you don't have to change anything. So it will work as it is. Only thing is in the backend, you can see the database actually switched between your primary and standby when you are doing this. Okay. So here we are talking about a single availability zone and multi-availability zone setup. How it is done, right?